Every machine learning algorithm needs data. So collecting data can often be a painful part of the machine learning process, and manually going into specific records and collecting information is often not a really fun process.
So in this project, it consists of me. I'm the front end full stack developer, just primarily focusing on the web page where machine learners will be able to go reach out to.
And my name is Samson DeVol. I've been contributing to the back end as well as full stack, kind of collecting the data and putting it into a database for the front end to access.
And then our project partner is Patrick Donnelly. He runs the Soundbender Lab, which is where our project is kind of based off of. And if you want to find more information about the Soundbender Lab, you can go check out that link. So the problem that we were trying to solve in this Capstone project is collecting, cleaning, and filtering data is a cumbersome yet pivotal part to training and developing machine learning algorithms. And as we just touched a second ago, although information on historical music is abundant, it isn't accessible for AI and deep learning researchers to find and format the data that they need. So the objective is in this project, we're aiming to provide machine learning researchers a robust database of metadata, program images, OCR text, and supplementary information for classical music concerts. As kind of shown here at this example, there's lots of text and even like symbols you could extract from these historical concert programs. The concert program OCR project presents this historical concert data from the web and organizes it to be easily filtered for pertinent attributes, downloaded as a data set, and seamlessly fed into data frames for various deep learning algorithms.
So now I'd like to go through the solution to this problem of collecting concert data, as well as some of the system requirements for our project. A little overview here broken up into 3 steps. First, we're going to use a web scraping script to collect data from the digital archives and pump them into JSON files. We are then going to establish an ODBC, which is Open Database Connection, to parse those JSON files into SQL insert queries and populate that Microsoft SQL database. Then we will populate the web application, which we are using Streamlit, and you'll hear a little bit more about further on in this presentation. Here we just kind of have a pipeline image of our project. So we start with that digital archive. We chose that New York Philharmonic site. And then using Selenium, the automated web browser, we collect the data. And then using that ODBC connection with our database, we can insert that data, and then we can collect that data into our front-end application. So some of the digital archives, there are many on the web, such as these 3, the New York Philharmonic, Boston Symphony, and UK Archive. You can see there's a various number of programs that each of these websites host, as well as different data about these programs. So we decided to use the New York Philharmonic site because of the robust amount of data that they have for each of their concerts, as well as images and OCR, which is optical character recognition text. So to web scrape this, we have an example of a New York Philharmonic entry. We can see on this first image, there is concert metadata, and we can pipeline that into a JSON file with all that metadata, as well as the concert program image, which can be stored in binary, as well as the text from that image. So then we have our database on a Microsoft SQL server, and using that ODBC connection, we can write our SQL queries directly in a Python script to pump those JSON files into our database. Here we have just a little relational schema of our database with 3 entities: the concert metadata, program images, and program text. Okay, so now we would like to just demonstrate some of the code that goes into making this project work. We will begin in the GitHub repository for this project, which is under the Soundbender domain. and it's called Concert Program Streamlit. So here we have a collection of all of our files. We have a README put together, a short table of contents, including project description, repo navigation, design, and a little how to run the code. So we're kind of going to go through the steps for how to run the code. So this begins in the data collection folder, which has our web scraper script. Inside this script, we have a couple of global variables. You can initialize these to your liking. They will scrape the pages from the New York Philharmonic, starting from and going to these two variables here. And then we'll capture the metadata, OCR text, or images, depending on these Boolean variables here. So after you run that script right there, we can go into the database folder, which is where we make that connection with our Microsoft SQL. And we can run this based on the instructions here. So back here, we're going to have our New York Philharmonic data from our scraped, from our web scraper. Here we have a bunch of output JSONs. For example, if we look at one with metadata, you can see that each of these is a specific concert program. So then within the database folder, making a database connection, again, we kind of have some variables that you can declare to connect to your specific database instance. For us, we have a Microsoft SQL server in this Azure client right here. So here we can see we selected the top 100 from the metadata, and we can see all the data that we have scraped and inserted into our database.
Okay, so now for demonstration, I am going to showcase the front end. So here's our kind of landing page using Streamlit. Streamlit's a really simple way to kind of link to a GitHub repo to host something on a web page. So it's kind of like cloud hosting in a sense. And what I was able to do is kind of just write a couple sections about what this project's goals are. Of course, link to the actual GitHub where all the code is. And then I explain a little bit about the data set. So we chose a New York Philharmonic for this example. And then here I provided a couple of different samples that were scraped from New York Philharmonic. So they're kind of all in varying sizes depending on what you feel like grabbing. And in this little last section, we can actually access the data sets here. So this drop-down menu changes which sample you want to view, and upon changing, you get the data frame showed right here. And then more importantly, we can actually download this data as a CSV file. So it kind of works for all the samples here, even up to the fourth one, which is definitely a pretty big data set. And then, of course, we have contact information here. And then because Streamlit is kind of relatively new, they don't have too much in terms of styling, but they do let you kind of go into like a little settings menu here. And if you really want to, you can kind of change the theme, like dark mode, kind of make it look a little nicer. And then another thing I want to demonstrate for on the SoundBender Lab website is kind of how you navigate this as a machine learning researcher. So most likely I'd have a link to this GitHub repo, which would bring me over to this splash page. I'd scroll down, kind of see what's available right now. Maybe at this point, I just want to work on, let's say, the small set. So I would choose sample 1. And I can click download data CSV, and you can see it's going to download it right there. And then next, I will show you right here. You would import your sample data in the code here. And then let's say we are doing example running this data frame. So I'm going to paste a little script in here. So you can see here, we're kind of just pulling from the simple one CSV, kind of load it into a data frame, and we could just like say print what the first part of it looks like. So I can run it here. And as you can see down here, we just are kind of looking at the data frame that we just downloaded. So a machine learning researcher could maybe start with sample 1 and then go back to here and maybe download sample 2 and then kind of rinse and repeat. I'd probably recommend making a data folder like this as well. And then that's a good place for someone to get started, because then they can clean up whatever they want to possibly clean up on here, and then maybe run a NLP or like sentiment analysis model to kind of pre-train this data.
So now that we've showed you the working demo of our Capstone project, we would like to just touch on some future work. This project will be left to the Soundbender Lab for future Oregon State University researchers. We hope that these researchers can use this concert program data to develop deep learning approaches that associate descriptive terms, such as those within a concert program, that deepen our written and oral understanding of how music affects us emotionally. So with that, we would like to thank you for watching our final demo video, and goodbye.